Hi, my name is Suji Maniyam. I am an AI DevRel engineer. In this session, I'm going to walk you through some features of Data Prep Kit. This is a hands-on session, so let's do some coding. So the use case I'm going to illustrate is preparing a bunch of PDF documents for RAG. We are going to extract text from PDF documents, do deduplication, and also we are going to do document quality assessment and eliminate some spam documents. This is the overall workflow. I'm going to walk you through step by step. So you will see the link to the code in the description. Go ahead and get to the page. And here's the GitHub page for the sample code. Scroll down a bit. And we are going to run this code on Google Colab. That means you can just simply open the file and run on Colab. There's no need to do any setup on your computer. So very convenient. So here's how you do it. So go ahead, simply go ahead and click on this link to open this on Google Colab. Now I have the code open in Colab. So go ahead and simply say runtime and run all. Let's go through this notebook step by step. So step 1, here 1.1, I am figuring out if I am running this on Colab or a local Jupyter instance. Because if I am running on Colab, I need to do a few things differently. And this piece of code basically tells me if I am running on Colab or not. And you see we are. And if we are, look at step 1.2, I am installing some dependencies. Because remember, in Colab, every notebook gets its own sandbox. So any dependencies you need to install them. So we are doing a install of Data Prep Toolkit version 1 and human friendly. This step may take 1 or 2 minutes, so give it some time to complete. And sometimes they will ask you to restart the runtime. If that happens, you can. You don't need to. If you do restart the runtime, you can just continue from step 2. There's no need to rerun the install step. It's already done. So if you restart the runtime, continue from step 2. Let's look at step number 2. Here we are going to set up some configuration and utils. We already seen this piece of code, so to determine if you're running on Colab. And 2.2, we are setting up some input-output directories. Our input directories are input, and the output, we actually have a series of output. The way to understand this is think of it like a pipeline. If you look at the workflow, it's a multi-step workflow. Step 1, we are going to parse PDF documents and create a bunch of text documents. Then this becomes the input to the next stage. And that stage's output becomes input to the next stage, and so on and so forth. So that's why in step 2.2, you see we are defining multi-stage output. You can see the stages, right, defined, and the final output is going to be in this folder. Okay. And 2.3, we are defining some handy utilities to read and display data from Parquet files, and also another one to download files. And we will use these below. Now, step 3 is when we get to the data. I have a few PDF files. You can click on these and look at the PDF files. Let me show you one, for example. Say, let me download earth.pdf. So step 3, we are looking at some input data. These files are in GitHub. You can find them here. Click on this. Let me show you a couple of those. So first, earth.pdf. This is a very simple one-pager PDF. You see, right? A couple of paragraphs of data. And you might also notice I have the earth copy.pdf, which is an exact copy of this. I'm going to use that to illustrate duplicate removal. And also you'll see I have a lorem-ipsum PDF, and it has a bunch of lorem-ipsum text. Yep. And also another one called mass.pdf. And one more thing, spam.pdf. So you can see, right? Simple text. So I kept the files very simple so we can see how the data is being transformed as we go through the pipeline. If you are wondering why there's earth.pdf and earth2.pdf, these are almost identical files. Only one word is different. And I am going to use this to illustrate how we eliminate duplicates or near duplicates using our modules. Okay, let's get back to the code. So here we are downloading data if you're running on Colab. So here we are downloading those data files. As you can see, they are being downloaded. Step 4 is where we begin our processing. So first step is we are going to extract text from our PDF files. Now that we have them downloaded, we are going to extract text from PDF and we are going to extract them into simple markdown format. So in the code, this is step 4. The module I am using is called PDF to Parquet. You can look at the documentation here. It's very straightforward to use. So here's the basic code. So you can see I'm specifying which directory to read our files, input directory. It's going to produce data in output directory. And this line says we only want to process PDF files. So if your directory has a bunch of files like PDF, docx, HTML, you can limit your processing just to PDF. And then here, I am extracting the content in markdown format. That's it. So one line to transfer data from PDF into markdown. And while it's executing, you may have noticed it's downloading some models on the fly. Remember, we use docling to parse the PDF files, and docling downloads the models it needs at runtime. So the very first time you run this, it may be a little slow because it needs to download a bunch of models that it needs to parse the PDF. So let's kind of keep going and let's go to step number 4.2. Here what we are looking at is we are inspecting the generated output. And the output looks like this. So here you will see we are printing in a table format. So it's easy to read. So each file we processed has a row. So you see the file names, earth2.pdf, earth.pdf, and so on and so forth. And then in the contents column, you see the actual contents of the file. Some metadata, how many pages, how many tables. And you'll see we are computing hash for the contents as well. By the way, if you notice, you will see these two hashes are the same. Earth.pdf and earth.copy.pdf. Remember, these are the exact copies of each other. In the next steps, we will use the hash to eliminate one of these. Just highlighting it right now. So in step 4.3, we are looking at the output that is generated. Most of the columns are pretty straightforward. So it's the file name, contents we talked about, the hash we talked about, right? And also here's some content I'm printing out. If you look at earth.pdf, now you see the markdown format here, which is nice. And my spam PDF, right? Just a spam text. And my lorem-ipsum, just lorem-ipsum. So now we see the content of PDF files have been extracted. Now the next step of the workflow is creating what we call document ID. Basically what it does, it computes hashes. We are going to use these computed hashes to eliminate duplicates in the next step. So let me look at the code. This is step 5, right? It's very straightforward. If you look at the step 5.1, here's the doc ID module. And all I am doing is I'm telling it to read data from the previous output, right? I'm telling it to focus on the contents column. This is where we are going to compute the hashes. And then the hash is going to be stored in doc hash. That's it. The int ID is another column it will generate. I will explain what this is. And we are running it. And after the run, step 5.2, let's inspect the output. So in 5.2, if you look at the output, if you scroll to the right, you would see two new columns, doc hash and the int ID column. So every new column we add are going to be added to the end of this data frame. So this hash is being computed on the contents column, right? And the int ID assigns a unique ID for each document, which we will use later. That's it, pretty straightforward. Computes the hash. So next step, we are going to remove duplicates. In this one, we are going to focus on exact deduplicates, meaning identical documents. And here we are going to use the hash we just computed to eliminate the documents. The way it works is, imagine I have a bunch of documents. Let's say A and A are identical documents. They have exact same content. So our dedupe module is going to compare these two, and the way we compare them is using the hash. And one way to think about this is using Legos. If I showed you these two pieces and asked if they are identical, you will say yes, right? They're the same shape and same color, so they are identical copies. So that's exactly how we are determining duplicates. If they have exactly the same hash, they are duplicates. So the dedupe module looks at the hashes and eliminates one duplicate. So in this case, you will see one of the A's. So in this case, after running dedupe, you will see one of the A is missing. So let's see the code. So step 6, we are executing duplicate documents. And 6.1 is the code, basically a one-liner. You see, it's reading data from input folder, output folder, and it's looking at the contents column and the hash that we generated. That's it. Let's look at the output. That's 6.2. We are looking at the output. And this is interesting, right? If you look at the output, before we started, we had 6 documents. After, we have 5. So one document has been eliminated by dedupe. Let's see which document, right? If you scroll down a bit, so we will see earth copy is retained, but earth.pdf is not. Remember, those are exact copies, so one of them have been eliminated. There we go, right? So duplicate documents are filtered out. Next step, we are going to eliminate near duplicates. And the module we are going to use for this is called fuzzy dedupe. So continuing from the previous example, remember we have B and B dash. They're almost the same document, except one word different. So for our purposes, they are the same. So we are going to eliminate them. So after running fuzzy dedupe, it will compare the content. And basically what it does, it looks at the similarity index, and it eliminates one of them. Let's look at the code, and I will explain how this is working. So fuzzy dedupe on step 7, and kind of the way you have to think about this is they still use hashes, but they don't look similarity. So they use a threshold to determine if the documents are close enough. So one way to visualize this is, if I showed you these two documents and asked you if they are identical, you will say no, right? Because they're the same shape, but different color. But imagine, we are computing the distance, how close these documents are together. If they're kind of far apart, then we will say, they are different documents. But if they're kind of close to each other, maybe we can say they are pretty close. And that's exactly how fuzzy dedupe works. So let's look at step 7.1. Here's a fuzzy dedupe. And again, input output folder and the contents column, right? And it's going to look at the hash, and this is what determines how strict the checking is. This is a variable between 0 and 1. If you turn it higher, that means it'll do more strict checking. If you dial it down lower, then it's a little bit more lenient. So there's not like a right or wrong value in this. You have to kind of fiddle around a little bit with this setting to see which setting works for your documents. So we are running this fuzzy dedupe, yeah? And step 7.2, let's inspect the output. You will see here, before running fuzzy dedupe, we have 5 documents. Now we have 4. That means 1 is eliminated. Interesting, right? And if you look at the document that I eliminated, see, earth2.pdf is gone, if you remember. Why? Because that is nearly identical to earth_copy.pdf. So one of them is eliminated. Very good. So looking at the dedupes, first we did exact dedupe that eliminated exactly similar documents. Then we did fuzzy dedupe that eliminated similar documents. So we started with 4 documents here, and we ended ending up with 2. Pretty good, right? And the next step of the process is we are going to assess the document quality. This is going to help us eliminate spam documents, like lorem-ipsum documents, things like that. So let's look at the code. Next step, we are going to check for document quality. In my document set, I have 2 documents. One is spam, one is lorem-ipsum. We are going to eliminate them. And the way we do that is by running the document quality module. It goes through the documents and it'll give you a score or a flag. So it flags A as having spam, and it flags document B as having lorem-ipsum text. So we are going to use these flags to eliminate low quality documents. Let's look at the code. This is step 8. It's called document quality. Again, this is the module, doc quality. We are running it. Again, input, output, as you see. And I'm asking you to concentrate on the contents column to scan through and flag any content that is not correct. We run this. And after we run this, step 8.2, look at the output. So if you scroll to the right a little bit, remember we had all these columns before, but now we have a few more columns starting with doc queue prefix. So document queue actually computes a bunch of different metrics. So here you see one metric that is the average length of a word in the document. Yeah. And how many sentences, right? Oh, here we go, right? Here's the lorem-ipsum ratio. And you can see one of the documents tested positive for lorem-ipsum. And I'm sure, right, if you look, so trace it back, it's our lorem-ipsum, right? So, and also another column we are interested in is called contains bad word. And you can see one document is flagged. It's true, and you know which one that is. It is the spam.pdf, right? So this is flagged as containing bad words. So which is pretty good, right? And it calculates other metrics too. For example, this is kind of an interesting one, like how many bullet points or the ratio in the document. You can look at some of these metrics. These are pretty interesting. Now, in our case, right, we are going to basically eliminate documents that have bad words and placeholder words. And the way we do this is step 8.3. So I'm basically eliminating documents. I don't want anything that has the bad words. So I'm looking for this flag. We only want documents that are not flagged, right? So we're looking for false. And also I'm looking for lorem-ipsum ratio to be 0. I don't want any lorem-ipsum mention at all. And that gives me clean documents. And if you look at this, only 2 documents made it, earth copy and mass, right? And the contents are good quality. And that's what we wanted. Step 9, finally, I'm just copying the output into the output directory. You can actually see this. If you click on this little icon here, it's going to show you the output folder. And you can see our chain of output, right? 0, 1, 2, 3. This is how the pipeline output is saved. And our final output is under output final. And I just save them into the markdown directory. And you see I have 2 files, earthcopy.pdf, .md. Let me open this up. You can see just a plain markdown and also mass md. So we end up ending up with 2 quality documents after the pipeline is complete. Pretty good, right? And that's it. So that's the entire workflow. We went step by step. So you can see I started with a bunch of PDFs, extracted text, then we compute the hashes, then exact dedupe, fuzzy dedupe, document quality, And after removing the low quality documents, we are ending up with 2 documents. So you see the entire pipeline. We are starting with PDFs. We go through the pipeline and ending up with good quality documents for our training data. So you just saw data prep in action. You see how easy it is to use. It's Python, it's open source, and there's tons of features. So check out the GitHub for more examples. And thank you.